Chapter 3.1, Statements and Logical Connectives. So in this unit, we're going to be going through the topic of logic, which follows from set theory. You'll see a lot of things are in common between them, though logic is going to feel very Englishy in nature. What's interesting about the study of logic is that it might feel a lot like an English class to you as we study it, because essentially it has to do with studying statements that we make verbally and deciphering them, analyzing them, making arguments, seeing like what does what we say really mean if we break it down into its most basic components. So studying logic can really help you understand the way people speak and what they really mean, or at least what they should mean if they're speaking correctly, in quotes. So, some history of logic. The study of logic began with Aristotelian logic, with Aristotle. The ancient Greeks were the first people to look at the way humans think and draw conclusions. Aristotle is called the father of logic, and this logic has been taught and studied for more than 2,000 years. Then came Gottfried Wilhelm Leibniz. So he believed that all mathematical and scientific concepts could be derived from logic, and was the first to seriously study symbolic logic, which is the type of logic we are mainly going to be talking about. In this type of logic, symbols, usually letters, represent written statements. So it's essentially taking our verbal statements and translating them into a bit more mathy way of looking at them, but it still represents these logical ideas. Then George Boole is said to be the founder of symbolic logic because he had such impressive work in this area. So Leibniz sort of started the whole thing, but then Boole made it big and popular. Then Charles Dodgson, which you may know as Lewis Carroll, the writer of Alice in Wonderland, was also a logician who used a lot of his studies of logic in the writing of his books, particularly Alice in Wonderland. So if you actually read through Alice in Wonderland, the book, not the Disney movie, you'll see that there is a lot of interesting logic used in that book, logical statements and arguments, etc. So, what is logic, and how does it relate to the English language? So we're going to need a lot of definitions for this one. But again, these are going to be a lot of things that you know. You might not call it what I'm about to call it, but these are things you know. It's very much like stuff you would have learned in various English classes throughout your life. So, first we have connectives. Connectives are words that connect different ideas. Words such as and, or if and then, together, paired together. So, a note on this is that there are two types of ors that we use in our language, the exclusive and the inclusive or. So, the exclusive or means that one or the other of given events can happen, but not both, and the inclusive means one or the other or both. Right? I talked a little bit about this when we went through sets, but here we're saying it a bit more explicitly. That you want to think of it how these two different ors work as like if I said to you, do you want to get pizza or burgers tonight? You would know that if you said both, that would be like a weird answer, right? You want to go to a pizzeria or a burger restaurant. You're not going to go to both of them. So that's an exclusive or. You have to pick one or the other. But if I said, do you like reading or games? You could absolutely say you like both of them. That's totally fine, right? So that was an inclusive or. So these things, I didn't say anything really different. It's just sort of implied in what is said, whether it's inclusive or exclusive. So you use both of these types of ors in regular language all the time, and it just takes a little bit of understanding what's being said to figure out what would make sense. Can I say both or not? For our purposes, throughout the study of symbolic logic here, we're only going to talk about the inclusive or, which is the one or the other or both. The exclusive or does have its place in symbolic logic as well. We're just going to ignore it for our purposes, so you don't have to worry too much about it. So in general, I'm only ever talking about the inclusive or from now on. Next is quantifiers. So quantifiers, essentially, quantifier comes from the word quantity. It gives you an amount. So there are words such as all, none, some, stuff like that. That gives you sort of a very general amount of things. So all of this, or just some of this, or none of this at all, or something along those lines gives a context for an amount. Then what is a statement? So this, again, probably something you have used this word before. You know the word statement, probably. But we have a very specific definition of it when we're talking about logic. So a statement is a sentence that can be judged either true or false. Okay? So labeling a statement true or false is called assigning a truth value to the statement. So that means that we wouldn't call an opinion a statement, because opinions can't be true or false. A sentence fragment can't really be a statement. A question can't be a statement, right? Because none of these can be judged as true or false unequivocally. You may think your opinion is true, but it's not a fact, right? Just because you think it's true. So we have two types of statements we're going to talk about. First is simple statements, which is just a sentence that conveys only one idea and can be assigned a truth value once again. So I am wearing a green shirt. Is that true or false? Well, right now I'm wearing a gray and white shirt. So you would just say, no, that is false, right? I conveyed exactly one idea and you can tell me whether it's true or false. So that is a simple statement. Then compound statements are sentences that combine two or more simple statements using connectives, usually. So like, I am wearing a green shirt and I have a cat, right? Well, we already know the first part of that is false, so the whole thing is going to be false. I also don't have a cat, so both things are false, right? I'm really lying to you right now. But that's what you really want to think about with these statements is, when are you being lied to? That's the question you want to ask. So sometimes you won't always know whether or not something is true or false, but we're going to get into what do we do about that. That's where the main study of logic, which is going to be our study of truth tables, comes in, is what if I don't know whether a statement is true or false? What can I do with that? But for right now, we are going to get into some more specifics about what we can do with statements and how we can combine them. So first we have the negation of a statement. So a negation of a statement changes a statement to its opposite meaning. This usually occurs by adding the word no or not or some sort of negative to the sentence, right? I have a cat becomes I don't have a cat, right? Yes, I had to add do not just to make it grammatically correct, but the point is that I added some sort of negative word in there. Or maybe I like cats becomes I dislike cats. So technically, dislike is adding a negative because I added the dis part of that. So there's different ways of how to structurally add this negation, but the point is you add one sort of not word in there, one sort of negative word to your sentence, or alter a word in your sentence just to change it to the exact opposite meaning. So because of that, a negation of a false statement will then become a true statement, and the negation of a true statement will then become a false statement. So I already basically used this example. The negation of I have a cat would be I don't have a cat. But I'll give another example that's off the top of my head. How about I can swim becomes I can't swim, right? Or I am wearing a green shirt again means I am not wearing a green shirt would be the negation. But also if I started from I am not wearing a green shirt, then the negation of that would be I am wearing a green shirt. So it kind of works both ways, where if there is already a negative, I can then remove the negative to get that opposite meaning, right? Or I could add a second negative and then we get into double negatives. So I am not wearing a green shirt does also mean essentially that I am wearing a green shirt. All right. So where negations get a little bit trickier is when we have quantifiers involved. So all of the simple statements I made before there were no quantifiers. It was just I am doing this, I have this, etc. I, right? But with quantifiers, we have statements that are more generalized to say all of this category of things. Quantifiers have to do with sort of categorical statements. So all cats have 4 legs, right? Something like that. What would the negation of that be? Well, it may be your intuition to say that the opposite of all cats have 4 legs would be no cats have 4 legs, right? But in fact, that's not the opposite. Because essentially what we're saying is that every single cat has 4 legs. To mean the opposite of that is, well, at least one of them doesn't. So it doesn't have to be all of them don't. Just at least one doesn't. To bring it to basically say that what I originally said was false, right? So in that way, we would say that the negation of all are is some are not, which we might not say it exactly like that, but the point is to say that at least one doesn't fall into this category, right? So if everything falls into this category, and then the opposite of that would be at least something doesn't fall into that category. Then the opposite of nothing, or none are, becomes just some are, right? So nothing, if I say there are, again, no cats have 2 legs, right? Then if I say, well, some cats have 2 legs, I am negating that statement. I don't have to say all cats have 2 legs to prove myself wrong. I just need to show that at least some of them do, right? And vice versa. If I started from some, then I have to say, no, there's none. And if I start from some aren't, I have to say, no, all of them are. That's the opposite. So let's look at some more specific examples. If I said, some books are novels, what would the opposite of that be? Well, according to this chart, the opposite of some are is none are, right? So some books are novels means that that novels exist, that there are some books that are novels. And so if I wanted to prove myself wrong, or to say the exact opposite of that, to say that that statement is false or whatever, the opposite to that would be, well, no books are novels, right? So either some are, or there's none at all. And so no books are novels becomes the opposite. Then all coins are made of gold. Again, I'm making this very generalized statement to say that every single coin that exists is made of gold. So you could prove me wrong by showing me at least one coin that's made of copper, right? So at least one is to say that some coins are not made of gold, like so. Now, which ones of these are true? Well, notice that some books are novels. That's true. And no books are novels would be false. All coins are made of gold is false. Some coins are not made of gold is true, right? They are opposite meanings. But let's say we had gotten this wrong. Let's say instead I had, written the opposite of some to be, let's see. If instead of saying this, I said some books are not novels. Like if I just added that not in there, and that was it. Okay. Now is that true or false? Well, nonfiction books exist, right? Nonfiction is not novels. So some books are not novels, right? Those nonfiction books are not novels. So this is true. And notice how it's not the opposite value? So that can't be the negation of some books are novels. Now if I had said all books are novels, well, that one is in fact false. but it doesn't feel like the opposite statement, right? Yes, it is. Yes, it technically has the opposite truth value, but it doesn't feel like we're saying the opposite statement, right? So even though we end up with the opposite truth value, that's still just not actually the opposite of what we were saying, because some books or novels kind of falls within there. So we wouldn't want to say that either. So that kind of leaves us with this one that has to be the direct opposite. And we can make the same argument for the coins ones. If I had said no coins are made of gold, that would still be a false statement, right? Because there are gold coins out there. So it wouldn't be the opposite truth value. And then if I said some coins are not made of gold, yes, that would be false. That would be true, but it doesn't feel like the opposite of what I said before. So there we are. All right, now let's get into the real meat of our subject. Is going to be symbolic notation. So taking all of these connectives, the negation, all these ways we can sort of mess with our statements, and we're going to make them symbolic, which means we're going to take them and write them in a way that's going to look a little bit like algebra. So we're taking English verbal statements and turning them into algebraic statements, kind of. Just so that they're a little bit easier to work with. We're not going to do actual algebra on them, but it is going to feel like we are. But what's interesting is that any operations we're doing, we're really doing on verbal statements. So we're combining English with math right now, and it's really kind of cool how this works. Okay, so how do we do that, though? So first, we can label any simple statement with a letter, such as P. So for example, we're going to call P, you are human, and Q is I like math. These are both simple statements that are verifiable, means they have a truth value. So you are human, it's hopefully true. I like math, that is definitely true. Okay, so let's start with the easiest one, is the negation. So for the negation, we use a tilde symbol, which is kind of read as the word not. Once again, we can use other words when we actually translate into verbal statements just to make the English make sense. But in general, we read the negation as the word not. So then the negation of P is written as tilde P, or not P, and would be read as you are not human. So if we have P defined as you are human, then tilde P becomes you are not human. Okay? So anytime you see a tilde next to a statement variable, just means you add a not to the original statement. Okay. So that's the simplest one just because it's only dealing with one statement. All the next ones, we have to combine two statements because we're using connectives. So first we have and statements, also known as conjunctions. So we use this sort of what looks like an upside down V. I like to sort of remember it as kind of like a capital A without the line, just because it's for and, right? So you're going to have to remember this, just like the union symbol, the U and the upside down U. We have the one that looks kind of like an A, but without the line for our and then we're going to have one that looks like actually a V for our or. So the union and the intersection symbols, very similar to the and or symbols, just pointier. They go together. There's a reason for this. They have the same purpose in logic versus set theory. The ands and the ors versus the intersections and unions. Okay, so we have this, again, upside down V that looks kind of like a capital A without the line, just to help us remember that it's and, is used for conjunction and is read as, again, the word and. So then the conjunction of these two statements, P and Q, would be written as P, that upside down V, Q, and read as you are human and I like math. So we just read all of P and all of Q. Now note that, once again, there are a lot of different words that could represent the word and, in the same way that when we use a not statement, or when we're identifying a not statement, a negation, we might not have the word not in there. We might have some other word, or we might just have some negative word in there, like dislike instead of like, right? There's a lot of ways we can verbally say things. So for and statements, the word but, however, nevertheless, any of those are conjunctions as well. But is the one that you're going to see the most in this class, but besides and. So if you see a but statement, logically it means the same thing as and. Yes, colloquially we have reason, there are particular times when we would use but instead of and, right? But when we talk about logic, they basically mean the same thing logically. It means we're combining two things together in this particular way that we're going to study a little bit later exactly what this means, but just trust me when I say and but are the same thing logically, even if there's a little bit more to it when you're writing in English which one you would want to use. Okay, so here we have our first example. If we wanted to write the following conjunction in symbolic form, I've highlighted it in colors and all of that so that we can kind of see what needs to stand out to us. So first, your first step in anything like this is to identify the simple statements, the ideas at play here. And those are the things that I have highlighted here in blue and green. So I'm going to name them some letter. Again, P and Q are the default letters that are used, like they're just the ones that we tend to use, like X and Y in algebra, but it's entirely okay to use a letter that actually sort of goes along with the sentences being made, just so you can remember which is which a little better. So here I'm going to use T and R. So T is Elton John is on tour, and R is Elton John is recording a new CD. So T for tour, R for record, right? You need to state the whole statement, that way we know exactly what you are defining as T, what you are defining as R. Then, to put it all together, we have T, Elton John is on tour, has a not placed into it, right? It has this, this not right here. Okay, so if we want to put that not there, that's going to be our tilde, right? And this but, like I just said, the but is a conjunction, like an and so our and symbol is this. So we've got negation. What are we negating? We're negating T, and then and nothing is happening to the green one, so this just ends up being R. So we get negation of T and R. So once again, remember that this symbol can represent and or but or several other words with similar meanings. But usually it's going to be and. If you see the word but, it's also that. Alright, so our next symbolic notation is going to be the disjunction. So here, the disjunction is our or statement. So like I talked about before, the or statement just takes that and symbol and flips it up so it actually is like a capital V. Again, it's not actually a V in the same way that the union symbol is not actually a U, but it essentially looks like one, right? So, capital V, it's read as or. So, unless otherwise stated, again, we are talking about the inclusive or. The exclusive or actually has a completely different symbol. It looks like this, but we're not going to use that in this class, so it doesn't matter. So, then the disjunction of P and Q is written as P, V, Q, and read as you are human or I like math, given the P and Q that I stated earlier. So, let's see another example. Here is one where I am giving you the P and Q to start from. So P is Camilla will take chemistry. Q is Camilla will take French. If we wanted to write Camilla will take chemistry or Camilla will take French in symbolic form, again, there's no knots in this one. This one's pretty simple. We just need to identify our connective. Our connective in this case is the or, so that's going to be our V. And we've got our two statements, the P and the Q, and that's it. P, V, Q. Done. So this is nice because I kind of highlighted for you what was what, but remember that whenever you're trying to break down a statement and you're trying to identify what are the parts to it, Usually you want to look for your ors, your ands, etc., and anything that isn't that is going to be the statements that you need to, or the simple statements that you need to give some sort of letter representation. But search for anything that is sort of a negative word, like not, or anything like that, so that you don't include that in your simple statements. Okay, so a little bit more about compound statements. We've seen a few of them already, but I just want to give a little bit more. So statements consisting of two or more simple statements like the previous examples are called compound statements, right? So compound statements use connectives. We've learned about and, or. We'll get to if, then, and if and only if. Those are the only other ones that we're going to talk about in this class. When a compound statement contains more than one connective, a comma can be used to indicate which simple statements are to be grouped together. So this one's a little bit important and interesting because we know that quite often in when we're speaking, we tend to have a lot of ideas at once, right? So we might say more than just two things separated by an and, right? So we want to be able to turn basically any sentence into these symbolic logic statements. And so, well, what if I just have idea, comma, and idea, right? What do I do there? Well, those commas, I have to really pay attention to what those mean, etc. Sometimes we'll have ands and ors and all of that strewn throughout a sentence. Using those commas to sort of figure out where one idea ends and another idea begins is kind of important. So again, in order for all of this to work, it does require a little bit of, it does require the sentences we're translating to have decent grammar, but it's, this isn't a grammar class or anything like that, so don't worry, it's not going to get too intense. So, when we write the compound statement symbolically, the simple statements on the same side of the comma are to be grouped together within parentheses, okay? So, let's see that at work. So here I have P is dinner includes soup, Q is dinner includes salad, R is dinner includes the vegetable of the day. So, if I want dinner includes soup, comma, and salad or vegetable of the day versus dinner includes soup and salad, comma, or vegetable of the day, what is the difference between these? So, we want to think about this first one has a comma and then the and is after the comma. So that's a little bit tricky, right? Because you might think soup is P, salad is Q, and vegetable is R, right? We've got this or, we've got this and that's the same here too, right? These have the same breakdown except for the position of that comma. But what do the commas do? So here we've got soup and salad are grouped together, and this is easy. I can just put my parenthesis where that comma is and then make sure that I actually enclose everything together. So that means soup and salad are together. The ideas of soup and salad are together, and then or vegetable of the day is a separate thing. So B is a little bit easier than A. So I'm just actually going to go over B a little bit more first. So for B, this means that I can get both soup and salad, or I can get the vegetable. I cannot get soup and salad and a vegetable, right? It has to be, I can get both of soup and salad. Like I can get the soup, I can get some, some tomato soup and I can get a salad with it. Or I can get the mashed potatoes. Those are my options. So that's what this shows, is that the soup and the salad are grouped together in parentheses. I can get those together. The vegetable is separate. Now for the other one, it's saying I can get soup and one of salad or vegetable of the day. So in other words, I have to choose between the salad or the vegetable, but I can definitely get the soup either way. So instead of, you may wish to place a parenthesis right here, but that would be poor form, because we never put a parenthesis next to a symbolic operation, a connector, right? Because we need parentheses to enclose the statements, and P being outside parentheses basically mean it's unreadable. Like, it doesn't mean anything, okay? So you have to think of these, the ands and ors, and once we get to the if-thens, etc., you want to think of them like operations, like plus, minus, times, all of that. So, generally, if I have just two numbers, right, if I put like the number 2, 3 plus 5, something like that, right? Yes, we know that we can do this in algebra because we know that this means 2 times, right? But when we're talking about logic, there is no default this means multiplication. This would be like saying 2 and then nothing, like no operation. It's just 2, which is meaningless to us, right? It doesn't do anything. It's not operating with the parenthesis. The parenthesis isn't an operation. So there has to be something there. So in logic, we don't have a default multiplication that happens. There's nothing. We have to have the operation, right, for it to mean something. So we can't put the comma here because, again, it would also be like saying 2, comma, plus 5, which we wouldn't do. I know, again, that might make you think, oh, 2 times positive 5, but that's not what that would mean, right? We have this operation next to the parenthesis. What are we adding the 5 to? Doesn't mean anything, right? So we can't put the parenthesis here because this thing is an operation just like a plus sign is an operation. So we never want it to be on its own. It has to have one thing on either side of it. So our only options are the way I've placed the parentheses here, or this is the other option because they have to be paired together. So now, let's read this out. Soup is alone, and we can have soup and one of these two things, right? Salad or vegetable of the day. They're together. So again, yes, we didn't put the parenthesis directly where the comma was, but we just sort of shifted it over to make it make sense. Because verbally, we put the comma before the and, but idea-wise, it's like having the comma after the and. So we put the parenthesis where the comma kind of interacts with the and. We're just putting it on the other side. So now we've grouped together the ideas of salad or vegetable, because that is a grouping, saying one of these two things, and we can have soup no matter what. So we pick, and then we get soup, no matter what. So here it is in nice colors for anybody who wants to see it like that. All right. So here we have an idea where, an example where we are going to now translate from the symbols. So if I'm giving you that P is the house is for sale, and I'm giving you that Q is we can afford to buy the house, we want to write the statements in words. So I have negate P or negate Q, right? This is an or. This means not. This means not. So not P means the house is not for sale. And then not Q means we can not afford to buy the house. And then we want to stick an or between them. So together we get the house is not for sale, or we cannot afford to buy the house. Done. So it's kind of like a direct translation, right? Just plop in those nots where they need to be, put an or between them, and you're done. When we have parentheses in here, it gets a little bit trickier, especially with a negation outside the parentheses, okay? So negation outside parentheses means we are negating this entire statement, which, just like with the set theory where we had A intersect B complement, we learned that this is not the same thing as A complement intersect B complement, right? It's not that. It is instead A complement union B complement. That rule works in logic too. It is still called De Morgan's law. It's just, okay, well, now we make this a V and we make this an upside down V, and this becomes the negation instead of a complement, but it's the exact same law, right? This we're going to talk a lot more about this later, so you don't need to worry about this, but the point I want to make is that no, you cannot just bring this negation in. It doesn't work that way. Like, there's a whole rule about it that we have to establish, which again, we will be studying later in more detail. So don't worry about it right now. Just pay attention to the position of those parentheses. So how does this work then? Essentially, what you want to do is you want to make some sort of all-encompassing statement here. You want to say, not just add a not to everything that's there, and not just say, it's kind of like just saying the word no at the beginning of your sentence. No, all this stuff. But to get it to sound right in English, once again, there are a lot of ways we can say this, but essentially the easiest one is just to start with, it is false that, or it is untrue that, or something like that. Because basically what that establishes is that everything after this, I'm saying is wrong. Like, everything I'm about to say has to be, I'm actually saying the opposite of it. It's wrong. It's the opposite truth value. So we get here, it is false that the house is for sale and we can afford to buy the house. So this is a way of sort of parenthesizing this whole statement and negating it. There are multiple ways we can say this again in English, but that's kind of the easiest one. The one that you want to default to is just, it is false that, or it would be untrue to say this, or something like that. So it's like you're starting your sentence by saying, I'm lying to you right now. Or what I'm about to say is a lie, basically. So everybody's on the same page. Alright, so that's our ands, our ors, our commas. Next, we have the if-then statements. So if-then statements are kind of the trickiest of all of our types of statements because they are the only type of statement that the direction really matters of what comes first and what comes second. And we'll really get into that a little bit later, but first we use an arrow symbol. So when I say direction, I mean what direction is that arrow pointing? This is going to matter. Now you will see it as both a double and a single arrow, so notice 2 lines or 1 line. I tend to use the 2-line arrow because I like to use 1-line arrows for other things within this class, so I just stick with the 2-line arrow, but I believe in the homework and such, it tends to use the 1-line arrow. Just realize that an arrow of some kind pointing from left to right, that means the if-then statement, also known as the conditional. We can also, instead of saying if-then, say it means implies. So, with the if-then statements, essentially, it's read we have something implies something else, or if one statement, then another statement, right? The antecedent is the part of the statement that comes before the arrow. This can also be called the hypothesis. And then the consequent is the part that follows the arrow. This is also known as the conclusion. We are going to use antecedent and consequence here, or consequent, but there's multiple different names for these things. So then the conditional of P and Q, which remember, P was you are human, Q is I like math from my original examples, would be P arrow Q is if you are human, then I like math. Q arrow P is if I like math, then you are human. Notice those have 2 completely different meanings, right? I mean, yes, they are pretty much nonsense, but regardless of the nonsensicalness of the statements themselves, they would mean something different. It matters which statement comes first in an if-then statement. Whereas if I say, you are human and I like math, versus I like math and you are human, those mean the same thing, right? I can kind of switch them around and it doesn't matter. But for an if-then statement, I can't switch them around. It does matter. So, we'll get to some kind of better examples of that in a moment, but actually, I'm going to just give one right now. Let's say, if I said, let's see, if it is raining, then you will get wet, versus if you get wet, then it is raining, right? Those would have 2 different meanings, because they're true in different, they are true or false for different situations, right? Because if it's raining, then you get wet means like, oh, you didn't have an umbrella, you went outside. But if you get wet, then it is raining. Well, what if instead you were just swimming, right? Doesn't have to have been raining, right? So that's generally just false. Like, there's plenty of reasons why why that could not be true, right? So it's like the direction of this matters. Again, we're going to explore that a lot more later. There's like a whole section on that sort of situation that we're going to get a lot more into the if-then statements a bit later. So if you're a little confused on why the direction matters right now, don't worry, we'll get more into it. But let's explore just getting our symbols out there first. So, the painting is a fresco. It's going to be P, and the fresco is a type of painting. Q is the painting is by Michelangelo. So if we have if the painting is a fresco, then the painting is by Michelangelo. This is our simple if-then statement, or our most basic if-then statement. There's no nots or anything like that. So if the painting is a fresco, then the painting is by Michelangelo. One thing to note here is once again that there is both an if and a then, right? But our symbol always goes between, our operation symbol, our arrow in this case, always goes between two of the statement symbols, two of the letters. Just like I was showing before, where we wouldn't say plus 5, 3 and mean 5 plus 3, right? We wouldn't say that. There are ways to say that, but that's a different, there are meanings to that, but that's kind of a whole different study that we're not going to get into. So here, we need our plus, which is our arrow in this case, to be between the P and the Q. So in this case, it will be P arrow Q. So we kind of ignore the if part of this, which you can ignore that verbally as well, because I could also say the painting is a fresco, then the painting is by Michelangelo. I could also ignore the then. I could just say if the painting is a fresco, the painting is by Michelangelo. Like, there's a lot of ways we could say this, so you really have to pay attention. But the arrow still goes between the two thoughts, right? So if the painting is by Michelangelo, then the painting is not a fresco. So here we've got this not. Notice that this is not P here, so negation of P, and Q is over here, so we end up with Q, arrow, negation of P this time. And here we've got our it is false that, right? So how does that work? That's our big old parenthesis around this whole thing with the negation. So if the painting is by Michelangelo, then the painting is a fresco. Well, that's our Q, our arrow, and our P again, like so. One note I need to make now, but I will probably make it again later, is, like I said before, you can not write the if, or you could not write the then here, right? But the most common error, this is an actual error, is to, instead of writing if then, is to write an if here. That is wrong. If you write the if there, it means this statement, actually, just this part of it, right? Because the if gets paired with the green statement, like it is here, right? So this is a completely different statement. This would be if Q then P, even if we're writing it like this. So I know verbally we often say something like the painting is a fresco if the painting is by Michelangelo. But that, if I twist that around, it would be the same as saying if the painting is by Michelangelo, then the painting is a fresco, right? It means this. So if you put your ifs in the middle, you better know which direction that arrow is going. Because in fact, if in the middle means this guy is going that way. The arrow is going from here to here. So please don't put your ifs in the middle. I'm begging you. You will get it wrong. Every single time I teach this class, multiple people do this on the exams, and it's incorrect. Like, you're going to get marked wrong. Do not put if in the middle. It doesn't mean what you think it means. The if gets paired with the statement it's next to. So the if is always with the first statement in your, in this. So it's if this, but wherever that if is goes with the first statement. So if the if is in the middle, that means The first statement is the second thing. So don't confuse yourself by trying to put your ifs in the middle. It's if and then, or if you do want to confuse yourself, you can put it in the middle, but you better get the direction of your arrow right. I just want to make that very clear. If you're confused on that, please ask about it. Alright, so our final type of connector is the if and only if statement, also known as the biconditional. So this is one that we don't often say verbally, but we do have a lot of situations where it comes up. It's more of a, like the actual if and only if statement tends to come up most in math, in mathematical definitions especially, or theorems, but also comes up in like legal arguments, etc. A lot of this logic stuff comes into legalese, but you know the idea of this, even if you've never actually used the words if and only if. So we use the symbol of a arrow going in two directions, right? So again, you may see it as a single line arrow or a double line arrow. Either way, they're the same thing. So sometimes we will shorten if and only if to IFF, which yes, indeed, is read as if. Mathematicians are weird sometimes. So we're going to explore the meaning of this a bit later, but in general, if and only if is a shorthand way of saying both if P then Q and if Q then P, like it's to say both of those together. So the biconditional of our P and Q from before would be, you are human if and only if I like math. Once again, this is one where the whole statement is just plopped in the middle, right? So just like the and or the or, just gets put in the middle between them. The only one that's different is that if-then. That's why I said it's like the trickiest one is the if-then statement, because the if-then has a part up here and a part here, right? But everybody else has it has the statement exactly where the symbol is. So it's a lot easier to translate as long as you remember what the symbol actually is. Alright, so here's our example. If we have P is Alex plays goalie and Q is the Huskies win the championship, then our first thing is just, again, we've got our P directly, our Q direct, and then we just translate this into if and only if. So it'll be Alex plays goalie if and only if the Huskies win the championship. We have to say the whole thing. If you say IFF, that's also fine, but it has to be one of those two. Don't shorten this to just if or just only if, because that would be wrong. It has to be both. That if and only if has a very specific meaning in logic. So you need both, because it's what gives us this two-directional statement that's saying, like, both of these things have to be true together. So next we have our Q. Nothing interesting happening there, but then we have a not P. So this will be Alex doesn't play, I guess is how we'll say that nicely. So Alex doesn't play goalie will be our P, and then again with the if and only if. So the Huskies win the championship if and only if Alex doesn't play goalie. And now we've got our negation outside of parentheses. We remember this means we will translate it into something like it is false that whatever is inside. So what's inside? We've got P. We've got negation of Q, so the Huskies don't win or won't win, something like that. So that's that. And so we get it is false that Alex plays goalie if and only if the Huskies do not win the championship. Alright, so here is just a brief summary of all of those connectives. I suggest, like, take a picture of it, put this in your notebook, something like that. Here's everything from this chapter, except for the quantifier stuff, which we will, again, get into a bit later. So we'll see that again.